Hello my dear students. Today I present you with another video lesson. In this session we are going to carry forward our chapter motion. But before starting, let's have a recap. In the previous lesson we have learned about rest and motion, types of motion, physical quantity and their types, distance, displacement and their differences, uniform and non-uniform motion, speed, velocity, acceleration, deceleration, graph, along with its slope and area, and their relations. We have also learned about equation of motion. So basically, in today's class, we are going to discuss and prove three equations of motion by graphical method and then discuss some in-text questions. Let us begin our class for today.
Imagine an aeroplane is accelerating on this runway. And let's say when that aeroplane is somewhere over here, we start our timer and let's say it has some velocity. That's why I've blurred it to show that it's moving, it's not at rest. And let's say its velocity at that point is u. And the question we want to try and answer in this video is after some time, let's say t, where will this aeroplane be? And what will be its new velocity? What I mean is, if we wait for some time t, we can kind of guess the aeroplane will be somewhere over here, but it'll be a little bit faster because it is accelerating, it's constantly increasing its velocity. So now the question is, what is the velocity at that point? And how far would it have traveled? And because questions like these are very common, let's build equations to calculate these things. And one of the ways to calculate them and build equations is by drawing a velocity time graph. Look at this graph. It's also telling us the same story. When we start our timer, that's when time is 0, the velocity of the aeroplane is u. And after time t, the new velocity of our aeroplane is v. And a very important thing to notice is because we've drawn a straight line, this means that the acceleration of our aeroplane is a constant. But what does that mean? Well, that just means we are assuming that the velocity of our aeroplane is increasing by the same amount every second. For example, if initially over here its velocity was say 20, next second it say it becomes 25, then the next second it should become 30, again increase by 5. Next second it should become 35. It should always increase by 5. That's what we mean by constant acceleration. So we'll go ahead and build equations for velocity and displacement for constant accelerations. All right, let's do this.
So here, this is the same velocity time graph on your screen where the x-axis denotes time in second and y-axis denotes velocity in meter per second. Let us take O as origin and the increasing straight line AB as the constant acceleration graph, where OA is denoted as u, which is initial velocity, and from time axis to point P is final velocity v. Now, to prove the first equation of motion, that is v equals to u plus at, we need to find slope of velocity time graph. Here, in the given graph, the lower point is A and the upper point is denoted as B. Hence, according to the rules of slope of the graph, we have to draw a straight line from the lower point A parallel to the time axis and from upper point B parallel to the velocity axis as well. Both the straight lines intersect at a point said to be D, and the elongated line BD intersect at a point on the time axis named C. So here we can denote BD as V minus U, which is basically change in velocity. Now here in this graph, OA is equals to U, which is initial velocity. OC is equal to T, that is time taken. BC is equal to V, which is final velocity. And BD is equal to V minus U, that is change in velocity. So here area of OABDCO is divided into two parts. First, triangle ABD, and second, rectangle OADC. As we know that the area of a velocity time graph gives us displacement, so we can say that the area of OABDCO is equal to area of ABD plus area of OADC, or it can be written as S equals to half AD multiplied by BD plus OA multiplied by OC. After putting the values, we get the equation 1, that is S equals to half T multiplied by V minus U plus U multiplied by T. As we know that V equals to U plus AT, or we can say V minus U equals to AT. So from equation 1 we get S equals to half T multiplied by AT plus UT, or we can say S equals to UT plus half AT square. Hence prove the second equation of motion, that is S equals to UT plus half AT square. Next, we will be moving towards our third and last equation of motion. Having the same given data, here we have the area of trapezium OABDCO. As we know that the area of velocity time graph gives us displacement as S, so here area of OABDCO can be written as OA plus BC divided by 2 multiplied by OC, which can be written as S equals to U plus V divided by 2 multiplied by T, which is equation 1. As we know that V equals to U plus AT, so you can write T equals to V minus U divided by A. So from equation 1 we get S equals to V plus U divided by 2 multiplied by V minus U divided by A as we put the value of T. After simplification, we get S equals to V square minus U square divided by 2A, or it can be written as 2AS equals to V square minus U square. Hence, we prove the third equation, that is 2AS equals to V square minus U square. Now, we will be move ahead with some in-text questions. For your better understanding, I will be reading out and simultaneously explaining the numericals given. First, what can we say about the motion of an object whose distance time graph is a straight line parallel to time axis? We have already discussed in the previous session that when an object is at rest, its distance time graph is a straight line parallel to the time axis, as you can see in the given graph. Second, what can you say about the motion of an object if its speed time graph is a straight line parallel to the time axis? It has also been discussed in the previous session that when the object is moving uniformly, its speed time graph shows straight line parallel to the time axis. Third, a bus starting from rest moves with uniform acceleration of 0.1 meter per second square for 2 minutes. Find A, the speed acquired, and B, the distance traveled. Here, given the initial speed of the bus u equals to 0, since the bus is initially at rest. Acceleration A equals to 0.1 meter per second square and time taken t equals to 2 minutes, which is equals to 120 second. Let small v be the final speed acquired by the bus. As we know that from acceleration, A equals to v minus u divided by t. After putting the values, we get 0.1 equals to v minus 0 divided by 120. And after simplification, we get v equals to 12 meter per second. Moving ahead, according to the third equation of motion, we know that v square minus u square equals to 2as, where is the distance covered by the bus. From equation 1, that is v square minus u square equals to 2as, we get 12 square minus 0 square equals to 2 into 0.1 into s, or 12 square, that is 144, equals to 0.2 s. So s equals to 720 meter. Hence, the speed required by the bus is 12 meter per second and the distance traveled by the bus is 720 meter. Fourth, a racing car has a uniform acceleration of 4 meter per second square. What distance will it cover in 10 seconds after it starts? So here it's given that initial velocity of the racing car u equals to 0 since the car is initially at rest. Here acceleration a equals to 4 meter per second square and time taken also given, that is 10 second. Now according to the second equation of motion, s equals to ut plus half at square, we get s equals to 0 multiplied by 10 plus half multiplied by 4 multiplied by 10 square, that is s equals to 200 meter. Hence, the distance covered by the racing car after 10 seconds from it starts is 200 meter. Last question. Under what condition is the magnitude of average velocity of an object equal to its average speed? We know that average speed equals to total distance traveled divided by total time taken, and average velocity equals to displacement divided by total time taken. So if the total distance covered by an object is the same as its displacement, that means if object travels in a straight line, then its average speed would be equal to its average velocity. So that's all for today. Hope the class was useful to you. Until next time, stay home, stay safe. Thank you.